Hello everyone. In this session, we are going to understand the concept of abstraction in Java, the fourth pillar in the object-oriented programming. First is the encapsulation, second pillar is inheritance, third one is polymorphism, and fourth one is the abstraction. Encapsulation, as we have already seen, is the process of hiding the data from the user by creating the capsules, look like capsule methods, which are getters and setters. Inheritance is the process of inheriting from a class and using the features of parent that enhances the reusability of the code, etc. And third is polymorphism. It is the ability of an object to get into multiple forms. Poly means many, morpheus is the forms or shapes. And classic example of that was when you create the object of a parent and instantiate it with the child 1 or child 2, then it gets into the shape of child or whatever child you instantiate it with. Like the object of an animal, when you instantiate it with the constructor of a cat, it becomes cat, as we have seen in previous sessions. And when you instantiate it with a dog or the constructor of a dog class, then it becomes a dog. So that's the example of polymorphism. Now in abstraction, which is the fourth thing or fourth pillar, is defined as the process of hiding the implementation details from the user. You know, it's the process of hiding the implementations or implementation details from the user and provide only the functionalities. Let users know that what methods they are using. No need to provide them the complex details as what is getting executed as part of those methods, what's the code as part of those methods. So assume a structure of multi-layer code, and on the first layer there is abstraction. So first layer of code will have only the methods, only the abstract methods, which does not have any code inside them, which does not have any implementation. So that is what is an abstract method. A method is called as abstract method when there is no implementation added to it. An abstract method can be added inside an abstract class. So we will see all these details via examples where the concepts will get very clear. For now, just understand that abstraction can be done in two ways. One way is by doing it through abstract classes and abstract methods, which we are going to see in this session. And second way is by doing interfaces, by creating interfaces. And that particular thing we'll see it in the next session. So let us create, and I've already created a class that is mobile. And to make it an abstract class, all I need to do is put a keyword abstract before the keyword class. So when I say abstract, so it's going to say public abstract class mobile. Now this mobile is the abstract class. And what does that mean is it cannot be instantiated with the keyword new. No one can create the object of the class. To create the object of any class, we declare the object with the class name, and then we instantiate it by using the new and the constructor. But the abstract class cannot be instantiated. It is meant for inheritance only. You can inherit from it and then use the features of it, but you cannot instantiate it because abstract class contains the abstract methods which act as guideline. So for example, in this case, we have this mobile as the base class, as the abstract class, and then we will have two more classes which are going to extend from mobile, which are iOS and Android. Now iOS and Android, and for example all other mobile devices types, whatever commonalities they have, whatever common functions, common methods they have, we can note those down over here in the mobile class, and then we can write the implementation for Android into the Android class and for iOS into the iOS class. So just for example, let me create one abstract method, public abstract void, and I'm going to say double tap. So simple method. And as this is an abstract method, it does not need any implementation. Rather, it cannot have any implementation. You cannot add it. You cannot add any code inside that. It will start to throw the compilation error. So two things over here. One thing is abstract class is the class which cannot be instantiated. You cannot create the object of it to use the features. You have to inherit from it to use it. That's the only way. And second thing is abstract class can contain abstract methods. An abstract method is the method which does not have any implementation, any code inside that. Now, what's the use? Now, whatever commonalities, whatever common functionalities we want to specify for iOS and Android, we can define them over here. We can say double tap or scroll up, scroll down, whatever common things we want to find out in between the similar classes, we can note those down over here inside an abstract class, in this case mobile, and implementation part we can manage into the particular classes, Android and iOS. So double tap implementation for iOS will create an iOS class, say iOS, and when we say extends mobile, and it will force us to implement all the unimplemented methods. So that is what this error is all about. It is saying the type iOS must implement the inherited abstract methods. So it is saying that as you are extending from an abstract class, you must implement the abstract methods from that abstract class. That's a compulsion now. And all we need to do is just get the method and implement it over here. No need to write this abstract keyword. And I'm just going to say sysout and iOS double tap. And the implementation code basically will go inside this method. Similarly, let's create an Android, and we will say that Android also extends mobile, and as soon as we say that, it is also going to say the same thing, that Android must implement the inherited methods. Let's add the unimplemented methods, and just going to say Android double tap, which is the code whatever is required to implement the method double tap. Now this override simply means this is the case of method overriding. The method is common in between the parent and child, and the child's method will override the parent's method. That's what it is saying. You can have this annotation or remove this annotation, which is fine. It's not going to make any difference. But having it is fine. That will help the reader understand that it is the case of method overriding, and kind of help him, debugging the code in the mind. So just to take a look again, we have one abstract class which contains one abstract method, and then we have two more classes, iOS and Android, which are extending from mobile, and they all share a method that is double tap. And in the mobile class, which is an abstract class, there is no implementation. The details are hidden in the iOS and Android class. The multi-layer architecture which I was talking about at the beginning of the session is this. The first layer is this, and whatever other methods are required to find out the commonalities, we can add all of those here, and we can write the implementation details into the iOS and Android. Now, how does it help? Like, for example, if I create a main class, let me call it as mobile main. In this main method, let me create, or let me define the object with mobile class, mobile m, and let me instantiate with the constructor of iOS first, and let's call the double tap method, and then let me instantiate it with the constructor of Android, and then let's call the double tap method. And when we execute, we know that as per the rules of method overriding, it will execute for iOS. When it is acting as the object of iOS, it will execute the implementation that is given in the iOS, and when it is executing for Android, it will execute the implementation from Android. So when we execute it, we'll see first double tap for iOS and then double tap for Android. Now over here, whenever we want to go to the implementation part from the method whenever we use the method. From that point, whenever we want to go to the implementation part, what we do is we take the cursor and then we do something like command and click, or like control or click on Windows, and then it takes us to the implementation. But in this case, it is hidden. It will always take us to the parent class, which is the first layer of the implementation. And if you dig deep, then obviously you will find out the actual implementation, not by simply doing command and click. It will always take you to the functionality part, not the implementation part. So that's the definition of abstraction. It is the process of hiding the implementation details from the user and provide only functionalities at the first layer. It can be done again in two ways. First way is by creating the abstract class, and second way is the interfaces. Abstract class is the class which cannot be instantiated. You cannot create the object of it, but the use of abstract class is just to extend from it. Extend from an abstract class and then implement the unimplemented methods, that is the abstract methods. The use of abstract class is we can common out the methods in the similar classes and provide the implementation in the specific subclasses. Okay, another thing, can an abstract class have a non-abstract method? Yes, it is possible. You can create a non-abstract method also. So you can say something like public void ABC, for example, and then provide the implementation, something like I am ABC. Now in this case, the non-abstract methods is not a compulsion for the subclasses to implement. Now the iOS, it is not implementing the ABC method, and Android also, it's not implementing, and there is no compilation error also. It means the non-abstract methods are not compulsory to implement, but abstract method is a compulsion to implement for all the classes which are inheriting from an abstract class. So to understand in one line, abstract class is more of like a guideline class which provides the functional details of a particular area, not the implementation details. Implementation details can be hidden in the multiple subclasses beneath. It will be just first layer of code with the abstract methods.